Hello everyone and welcome to the lecture on mapping techniques. The first mapping technique that we're going to discuss is choropleth mapping, also known as graduated color mapping. You are all very familiar with the concept of graduated color mapping. Essentially, each geographic unit is colored by the amount of something that it has, and an intuitive color scheme is used to show what has a lot and what has a little. But essentially what choropleth mapping is, it's used to portray data collected for a geographic unit. So anything that has an administrative boundary like states, counties, townships, school districts, house districts, and so forth. And essentially, when you are constructing a graduated color map or a choropleth map, data for the geographic units are grouped together into classes, and each class is assigned a color. This mapping technique is really excellent in terms of doing comparisons because you can easily compare your different geographic units very quickly in terms of the amount they have of a particular phenomena. An example of a graduated color map is seen here. This particular graduated color map is showing population of your county school districts, and intuitively we know that the counties that are the lighter blue have less population, while the counties the school districts that are a darker color are indicative of districts that have a larger population. So one of the key concepts in graduated color mapping is that you are selecting an appropriate color scheme that helps the map user interpret the data without even really having to look at the legend, because intuitively, if we just look at this and ignore the legend, we know exactly which school districts have low population and which have high population. Then we can use the legend to kind of see how the data is grouped and the amount of population in each one. Now, something to consider when you are making graduated color maps is the concept of data standardization versus raw totals. And this is something that we discussed a bit in last week's lecture when we were talking about mappable data. But essentially, data standardization adjusts for the varying sizes and shapes of the units. It isn't really a valid comparison to compare a small geographic unit with a large one, because theoretically a larger unit should have more of something, so it's not really telling you and conveying to you the density that might actually exist in that particular geographic unit. So there are three different types of data standardization that you can use. You can divide by two area-based raw totals. For example, divide the number of divorced by the number of married. You can calculate a rate, the number of suicides per 100,000 people, or you can calculate a summary numerical measure like median value of homes. Then, in terms of data classification, when we are actually creating these different class breaks, there are a number of classification methods that we can use to do this. The classification method that is used by default in ArcGIS is called natural breaks, and that essentially just finds the natural breaks in the data and then groups them together into classes. We, in the classes, when we were constructing graduated color maps, we kind of did a combination of two different techniques. We usually selected the natural breaks method because it's the default and does it automatically for you. Then we would actually go in and manually change the class breaks just to make them the breaks just a little bit more intuitive to map users. Now, if you remember, in ArcGIS, to make a graduated color map, we go into the layer properties of the particular data layer. We double click on it, and we go to the quantities area, and automatically graduated color gets selected. We pick what field we want to symbolize based upon, in this case the count field, and let me take one step back. The data that we're looking at right here is the number of HAC students per Pennsylvania House District. So the count field has the count of students in it for that particular district. And when you select the field, the natural breaks algorithm is automatically applied, and it automatically puts it into 5 classes. And up here is where you can see what classification scheme that you're using and the number of classes. If you would like to change any of these, you can do so by clicking on Classify. You can change your classification method here, and we'll get into these different methods in a second. And you can select how many classes. And then this area down here tells you about your data. This is the data histogram for this particular data set. So in the terms of the count of students, in the attribute table, the different districts go from 0 to 1269. So 1269 is the most students in one of the districts, while this represents the fewest. And you can kind of see that the data is how it's distributed along the number line, and the blue lines represent the class breaks. To change your class breaks, you can do that in 2 different ways. You can manually drag these blue bars, which is not the method that I prefer because it's hard to get it at exactly where you want, or you can come over here to the break values and manually change them. If you remember from the intro class, I always suggested working from the bottom to the top. If you go from top down, if you actually enter a value that is higher than one of these, it really messes it up and makes it really difficult to get it fixed quite right. So I found that working from the bottom up always works without fail, and it doesn't mess with your different classes. So if we are going to round this off, we have to go with a value higher than this number. If we go with a value lower, we're essentially including that district from the classification, and where that district would appear on the map would actually be a big empty spot. So we want to make sure that we always put something higher in here. So I'm going to put 1300, and then move up, and 800. Let's do 500, 250, and 100. So I rounded those off, and notice now my classification method changes to manual because I actually went in there and manually changed the class breaks to what I wanted. And then I can hit OK. Notice how those ranges change. Hit OK again, and then that is reflected in my area here. Now, if you remember from intro, one of the things that you should always do if you have values higher than 1000 is to add your thousand separators or your commas in your numbers, because it makes it more readable for the map user. To do this, you can simply just click on the word label, then format labels, show your thousand separators, and you can make other changes here if you wish. This is where you change all your number formats and such to make it just cleaner and easier to read. Hit OK, and then hit OK again, and we now will have a map showing, or a graduated color map showing where HAC students are located. So again, intuitively we know that the lighter colors are districts that have fewer HAC students. The darker ones are the ones that have more HAC students. So that's how you can change your different properties of your graduated color map. Okay, moving on. Now we're going to talk about the different methods of classification. As I mentioned, you're already pretty familiar with the natural breaks method of classification, since that is the ArcMap default, and you're familiar with the manual method of classification. We're going to also talk about equal intervals, quantiles, and standard deviation, so you can see what they do and when it's appropriate to use them for your classification method. This is showing the various classification methods, and it gives you an idea when it's good to use that particular classification method. For instance, the natural breaks classification method is used when you have an uneven distribution of values. Essentially, your data values are all over the place on that number line in your histogram. When you have a continuous distribution that you see like this, that's when equal interval is a really good classification method because it just is an easy to interpret method. Quantile is very similar in terms of how it's very similar to equal interval, but it's really best used when you have an even distribution. So let's say we have 50 states, and all 50 states are kind of equally distributed along here. That would be a good method for potentially symbolizing that phenomena. And then standard deviation classification is used when you're looking at your histogram and you see that you kind of have a normal distribution of values, like it has that bell curve to it. I'm not one to use this classification scheme very often, only because it's not intuitive for the map user. The point of a map is to help interpret data and to tell a story. If the map user doesn't understand the concept of standard deviation, they're not really going to understand the map. So I tend not to use it just because I don't think it promotes understanding in the way that some of the others do. But depending on what it is and who my audience is, then I might change my mind. If I have an audience that I know that's going to understand the concept, I'd go with it. But if you're fearful that they may not understand the concept, I would pick something different. But the purpose of classification, as noted here, is to make the process of reading and understanding a map easier, to show patterns that and trends that might not be self-evident. That your classification method can help make those patterns a little bit more evident. So equal interval. This essentially means that each class has the same interval between it. So it might be from like 0 to 5, 6 to 10, 11 to 15 is always that same interval. It's essentially when you use this in ArcMap, and let me just go in here. To change your classification method, you click on the Classify button. My ArcMap is running a little slow today, which I think you probably have all experienced. Change the classification method to equal interval, and notice what happens to these breaks, that they all become equal along there, and you can see where your values actually fall in here. If we hit OK, and apply, you can see how that changes up the map. But essentially, the interval between is 250, 255, so that's the interval that's there. This is not a scheme that I use frequently. It's an easy one to understand, which is why it's really useful, but I never really tend to have a good data set for it, because if you remember from this, it wants you to have a continuous distribution. A lot of times that's not really the case with the data that I have, so it's not one that I often use. Now, some advantages of equal interval is that it's really easy to compute this, and it's easy to interpret. Map users love this because it is very easy to understand. And then the intervals don't contain any missing values. You can interpret the map faster. So some definite advantages to this. But the disadvantage is that the class limits fail to consider how data are distributed along the number line. Essentially, if you don't have that perfectly even distribution, it's not a good scheme. And because it doesn't take into account that there might be areas where there are very few values, yet you have a class there. So that's one of the downfalls of equal interval. Now, the next one is quantile, and I always like this classification scheme. It was not one that I use very often, but essentially data are rank ordered, and an equal number of observations is put into each class. So for instance, let's say that we have 50 states and we have 5 classes. Essentially what will happen is each class will have 10 states in it. So essentially you divide the number of observations, in this case the number of states, by the number of classes, and that will give you the number in each class. Again, this is a useful one to use for the ease of computation. And because an equal number of observations fall into each class, the percentages of observations in each class will also be the same. And this is useful for ordinal level data. And again, very similar to the disadvantage of equal interval, it just fails to consider how things are along the number line. So it may not necessarily be, it might be like you might have 10 states together. 9 of them are at the one extreme end of the class, and the other ones at the other. They probably really shouldn't even be in the same class, but yet they're put together, which can be a downfall. So in order to make a quantile map, it's the same thing, where we hit on classify and select quantile, and notice what happens, and look how wacky that is. And that's kind of, you know, with the disadvantage for saying, and look at these break values. So it's a very interesting concept, but sometimes it's not the best for the particular data set that you have. So again, what we see here is there's an equal number of districts placed into every single category. Okay, standard deviation does consider how data are distributed along the number line, and classes are formed by repeatedly adding or subtracting the standard deviation from the mean of the data. This is great if your data is normally distributed or near normal. The mean serves as the useful dividing point, enabling you to contrast the values above or below it, and the legend contains no gaps. This really only works well for data that is normally distributed, and I think most of you probably had some type of math or statistics class that went over you know, the bell curve and a normal distribution, so it's really useful for data such as that. The other disadvantage is you have to know what standard deviation means in order to use it, or it's not really going to mean much. And again, that goes back to my earlier statement, is if you are fearful that your audience doesn't or may not really fully understand the concept, or you yourself don't, you might not want to use that particular classification scheme. So and standard deviation is kind of interesting in terms of what it produces. You're going to notice that it's very different than a legend that you see in all the other classification schemes. So if I go in here, change my method to standard deviation, you can see what happens, and you notice what your interval size is. That it's now you have to select what type of the size of your standard deviation, and then hit OK, and let's just hit OK again so you can see this. Now notice what the legend gives you. Essentially, this area here is essentially the mean, the normal value, and then as you move away from that, those areas are more different than the ones in here. So this is essentially is what you get when you get a standard deviation map. And one thing that you also notice with standard deviation that's been different with equal interval, quantile, and natural breaks is you have a different color scheme that's applied to it. It is not one that progresses from light to dark. It basically has the middle value, and as you move away from that middle value, the color changes, and it's called the diversion color scheme, which we're going to talk about in a minute. But because of the fact that you're looking at how different values are from normal, that's why you're having that particular color scheme. And then, of course, we all know a little bit about the natural breaks classification method, because it's what we've been using all along, whether you knew it or not. That's what it's been. But it basically places similar data values in the same class by minimizing an objective measure of classification error. It uses the Jenks algorithm to do that. I won't get into detail about that because I don't really think it's necessary. But there's also more than one algorithm that can be used to compute natural breaks. The advantages of natural breaks: it considers in detail how the data are distributed along the number line, and it assists in determining the appropriate number of classes. The disadvantages are difficulty in understanding the concept, and that you can actually have gaps in legends, which is something you're not really supposed to do. So those can be some of the disadvantages. So then, with all of this, what method should you select when you are making your maps? And the answer is different for every data set. Every file that you have is going to have a different answer depending on how the data is distributed along the number line. And this is a fun little chart that I came across a couple of years ago that I kind of like to use, but it basically tells you the situation and then the different classification method and whether or not it does a good or bad job of that particular topic, which I kind of like this. But you can see, in terms of understanding the concept, they all rank fairly well there. So now that we know a little bit about the classification schemes, and I really hope that you play around with those and just don't always take the natural breaks and manually change it, that you maybe kind of experiment using them to see if they actually do a better job of telling the story of your data. But one of the things that we have to do, irregardless of whatever classification scheme that we select, we have to also select an appropriate color scheme in order to make the map intuitive for our user. And we have to be considerate of the type of the kind of data that we are looking at, because that plays a significant role in the selection of a color scheme. So with graduated color maps that we've been making all along, I think we made probably 10 million Pennsylvania population maps over the years. That data is indicative of unipolar data, basically order that progresses from high to low or low to high, doesn't matter which order you put that in. Basically, and that is essentially how all the graduated color maps that we've created in the past have been, is that they progress from high to low. You also have bipolar, which basically has a meaningful dividing point, like temperature. Another example that I like a little bit better than that is elevation change. Like let's say a hurricane comes through North Carolina and you're gaining or losing sediment at various areas of the beach. You might have as your middle value 0, and as you move away from that you have elevation loss, elevation gain. So you have a nice neutral color in the middle of that scheme, and as you're moving away the colors gradually get darker, but that's when you would use, that's an example of bipolar data, because it's moving into different directions. And then balanced is essentially phenomena that coexist in a complementary fashion. And I basically just anything that's qualitative data, like a unique value map, essentially is balanced data or categorical data, qualitative data, however you want to refer to it. So that's what you would use there. So in terms of color schemes that you would use for the different type of data, if you're dealing with unipolar data, you want a sequential color scheme. If you're dealing with bipolar data, you want a divergent color scheme. And if you are working with balanced data, you want a qualitative color scheme. And this just gives you a little bit more information about the various types of color schemes. And this is actually available to you in the site that I'm about to show you, colorbrewer.org, where you can actually go and look at color schemes and create color schemes that are different than the ones built into ArcMap. So this is like an example of good and bad color use on a Choropleth map. The map of Ohio here on the left is a bad color scheme for this data set. The reason why is if we would cover up that legend with our hand and just look at the map, we would have no idea which intuitively which color is indicative of less or more, because to me it all looks like they're all a lot because of dark colors and so forth. So it's not an intuitive scheme. When we look at this color scheme used on the right, we see that there's counties that are light, counties that are dark, and intuitively we know that the orangish color means that there's more of something in it. So that's a really simple example of good and bad use of color schemes on a graduated color map. So the sequential scheme gives some order or sequence to the data, and again you can kind of just see different examples of it, but notice how you can intuitively tell that what countries have little and which have more. And the thing that's different about this is that this one is working with multiple hues. In intro, I always tended to say, just for simplicity's sake, pick like something that has the same like a single hue. It just goes from light to dark at the same kind of color, but that's not necessarily true. Something like this is fine, but you just have to make sure that it progressively gets darker. And then this is nice if you ever have to do. I love like black and grayscale maps because I think they can look really cool. But those are also great if you know you're going to be photocopying a map. You might as well just put it in grayscale to begin with. A diversion color scheme is essentially the importance is focused on the midpoint and then variations out from that midpoint. So you can see, like, this is a really good example. Change in the percent of labor force. This is like the middle value or the midpoint, and as you move away from that in decrease and increase, you can kind of see how it gets lighter going this way, then a little darker, lighter, and then a little darker. So that's an example of a diversion color scheme, and same over here, same kind of concept. So I'm going to show you how to make some customized color schemes, because it's just a lot of fun. And in some classes we did talk about this in intro, other classes no. It depends, like, if the question ever came up about color schemes. But let's say I'm going to go back with this. And actually I'm going to change data sets here completely. I'm going to make just a quick map here showing virtual campus enrollments of spring 2010. And when we do make this map, it automatically will select the color scheme, and it usually selects the last one that you used. And I use this blue one quite a bit, so that's there. But when I look at these, not all of these particular color schemes are appropriate for symbolizing enrollment. It has to be something that progresses from light to dark. Like, this is an example of a diversion color scheme, like the other one that has the midpoint and values that move out. These are examples of sequential color schemes. Again, these are divergent color schemes in here. So you just have to make sure that you pick appropriately. And again, I'm just going to stick with this, hit OK. And kind of a boring map because, of course, the areas outside of the hack service area are not going to have really any students, so all your values are really clustered here. But let's just say that we want to make a map with a customized color scheme because we're really bored with the color schemes that we find in ArcMap, and you will get bored with them really quickly. What we can do is we can use a website called colorbrewer.org, and this is actually in your getting started area, this link. So if you are looking for it, just go to the getting started area of the course and you'll find it. And there we are. So a little bit of background about Color Brewer. It is a website that was developed by a Penn State faculty, Cindy Brewer. She is a really well-known cartographer. She developed this to help you pick color schemes that are appropriate for the map that you're trying to create. So essentially what you do, you just go through the wizard that you see here, select how many classes that your map is going to have, and ours is going to have 5. Select what type of data you have, and ours progresses from low to high, high to low, so we're going to select sequential. And then you can pick with either a single hue color scheme or a multiple hue color scheme. And I'm a big fan of the multiple hue because one thing about like the single hue, sometimes the colors can look very similar and it's hard to distinguish the colors. And when you can't distinguish the color, your map is useless because then nobody knows what category it's actually in. And just as an aside, remember when you are selecting how many data classes you are, you should never really go over 7 on a graduated color map because the human eye can't distinguish differences in really more than that if you're using a single hue color scheme. So you got to be careful with how many classes you select, and I tend to pick anywhere from 5 to 7. I usually kind of stick with 5, but depending on the nature of my data, I might go more or less. So again, I'm going to take a sequential color scheme, and then when you click on any one of these, I'm a big fan of purple. You click on any one of these, it will give you a look over here. And notice that when I'm hovering over any one of these, it's giving us the color values in RGB, CMYK, and hexadecimal. And this will allow us to create the color scheme in ArcMap. So what we can do is go over here, and I'm going to select RGB so that we get the RGB values for every one of the colors. You can record those or export them, whatever you want to do, and you can also do other things over here that are kind of neat. You can, only show colorblind safe schemes, print friendly, photocopy safe. If you know that you're going to be having other things on your map, like let's say that you're going to be adding cities or roads, you can add those on here and kind of play around with the color so that you get something that you think is going to work well with the color scheme that you chose for your graduated color. And this is actually something you're going to be doing next week. You're going to be making what seems like a really simple map, and it's not complicated, but you're going to be making a population map of population in the United States in 1800, and you're going to have to add cities and counties and so forth. You have the other data to add on top of it. This helps you kind of select what color those should be in order to pop or to be seen on the color scheme that you're actually using. And that sometimes can be a challenge because while black might work really well on this purple color, maybe on this one it doesn't work as well. So it can be really tricky to get the perfect color coordination. So anyway, but back to the RGB area. So essentially what you would do is record these values, and once you have those values recorded, go back into ArcMap, and what you can do is double click on your data to go to layer properties, and then you just double click on the color that you want to change. So I'm going to double click on the first value, and for my fill color, I'm going to click on that little drop down arrow and then go to more colors, change this to RGB, and then type in those values that you had on the color brewer site. And this is going to take me a second because there's lots of numbers. And hit OK, it changes it. And then we go to the next one. Same process, we just go to more colors, change that to RGB, select or type in the numbers. And I'm going to keep going just to finish this out so you can see. So it takes a little time. And finally the last one. And there we have it. I can hit apply. And it's taking a second, and there we have it. And then our color scheme is shown there. And then we can hit OK, and there we have it. Now, a little other ways of doing a very similar thing, but cheating a little bit. Let's go to this data frame. It's the same data, but let's do this a different way. What you can do is you can actually just change the color of the first one. And excuse me, my light turned off. I need to go activate it. You can change the color of the first one according to this, whatever specifications you have. And go to the last one. Do the same. And now that you have the first and last one changed, select all of them and then go to ramp colors. All right, let's try that again. You should just select the first one and the last one by hitting Control, and then right click and go to ramp colors. It will automatically fill in the intermediate values. It's not the same thing that we had with this color scheme, but that's another way of creating a color scheme without having to go in and type all of those values. And you can hit apply and OK, and you have that particular color scheme. So let's go back to Color Brewer for a second. A couple of other things here that are useful. You know, we sat and typed in all these values. You can click on the export button and you can do this, a couple of different things with this. You can export your different color schemes. And it used to have, I believe it still does, a place where you can download, yes, the Excel spreadsheet that has all the color schemes in it. So that's actually cool, and I encourage you to download that, and I'll just do that right here. And you can kind of see all the different color schemes and the values assigned to them. When you do download this, this is just showing you a preview of it, but you'll have every single color scheme that's embedded in Color Brewer, which is pretty cool, and then it'll show you the color scheme there. The other thing you can do is you can download the styles here, and this is kind of fun. So if we go and download this, we can add this to one of our style sets. And when we unzip this file, I'm just going to copy that to a location. Now that I have that unzipped, I can go into my Customize area, Style Manager, go to Styles, add Style to List, navigate to where I have that, hit OK. Notice it shows up here, hit Close. Now, when I go in here, you can see a whole bunch of new color schemes, which is pretty cool. So it just changes this whole thing for you when you add that style. And again, the process to do that was to go to Customize, Style Manager, Styles, add Style to List, navigate to it, select it, and voila, you have some new styles in terms of color schemes. So that's something that's helps you make your maps a little bit more customized. So with that, I'm gonna end this video. Again, this week you'll be doing maps for a whole number of different mapping techniques. Keep all those techniques in mind as you move through the semester, because we've been making a lot of graduated color maps, but proportional symbol, dot density, and charts and so forth can go a long way in telling a story, and sometimes it tells a better story than what a graduated color map can tell. So you'll be going through dot density, proportional symbol, graduated symbol, and choropleth mapping this week.